best that yesterday's lesson didn't go up.
Cause a little bit
A little bit of angst for you there. Okay, so we'll skip the sketchpad stuff, and we'll skip the derivative stuff. So we'll get down to that kind. Okay, so let's talk a little bit. Question?
No, sorry. I was just gonna ask. I mean, for the homework yesterday. I was looking at this, and for all those ones that you just showed for like v shell equals whatever, should we just disregard those and just plug in for that one?
What I showed you was the derivation of where that formula comes from.
Okay.
Okay. So I'm also going to talk a little bit today about an algorithmic approach to handling these problems, because we have three different types. We've got disk, washers, and shells, and what you need to be able to do is figure out which method you're supposed to use, because eventually you're not going to be told, solve this volume problem using shells, solve this volume. So you're going to have to figure out which is which, and I'll give you some hints. I'll also give you some hints as far as deciding, should I be working in X's or should I be working in Y's? What's going to be on you is remembering, okay, so I'll show you how to figure out that you should be doing shells. What you're going to need to remember is how to do a shell then. What's the formula? So disks, washers, and shells are all note card worthy. You should have a note card with this formula on it, but this don't mean diddly if you don't know what it stands for. Okay. That X value is the distance that your rectangle lies away from the axis of revolution. Now obviously you're working in terms of Y, it would become Y, but we're talking general terms here where you've got a vertical rectangle. Most of the time that value will be X, because you'll be revolving around one of the axes. But of course we're going to look at some examples where we shifted away from the X axis or Y axis, and then that distance will change. F of X is the same thing as your Y value, which is also the same thing as the height of the rectangle. Dx is the thickness of the rectangle, so that expression, f of x dx, is the area of the rectangle. The rectangle being your representative rectangle. A and B are your limits of integration. We're taking representative rectangles from where to where. And you're going to have to remember that there's a 2 pi out in front of it. Pi for disks and washers, 2 pi for shells. Okay, make sense? All right. So that just illustrates what we've already talked about there. All right. Then I think we did this example, didn't we? We didn't do any examples, we stopped there. Okay, good, then this will be a good start. We've got a function, y equals 6x minus x squared. Any idea what that looks like? Good. It's better than nothing. What else?
Upside down parabola.
Upside down parabola. How do you know, Greg?
Because it's minus x squared.
Good. Anything else? Where does it cross the x-axis? Positive 6 and? No. 0. Now, why do we care? Well, if you didn't have a calculator for this problem, you need to be able to put together a sketch. Doesn't have to be an accurate drawing, but a sketch of what that function looks like. And then we also want to have it bound by y equals 0, also known as the x-axis. And we're going to revolve it around the y-axis. So we get that picture. And there's the parabola that we care about, bounded by the x-axis. So the shaded region is what's going to happen. We're going to take that representative rectangle and spin it and get a shell. No, you don't need to draw the shell. You just need the area that we're looking for, or that we're going to use to revolve, and the representative rectangle. Bridget?
Might be a little bit late in the game to access, but for each of these methods, are you only...
I thought you were going to ask me how to take a derivative.
Oh.
Might be a little late. I was just wondering how you take a derivative?
No, I got that one.
Okay, good, good.
But are you only rotating the rectangle, or are you rotating the whole graph?
We're taking that rectangle and just rotating that, and then saying, okay, if I can just rotate that puppy, then I can use an integral to add up all those other rectangles that I would have lined up.
Okay.
And so we don't have to do every single one. You just do one and then generalize it with an integral.
Is that the same for each of the methods?
Mm-hmm. One disk, integral for all the discs. One washer, integral for all the washers. Boom.
Is it a general rule that if you're rotating around something that is vertical, you're using the shell, or not necessarily at all?
Not necessarily. So this will be a good time to go through the process. Here's the method that I think you should be using to solve these problems. Okay? First things first, look at your rectangle. If your rectangle is vertical, you will be working in terms of x, regardless of what method you use. If your rectangle is horizontal, you're working in terms of y. I feel like I should write this down. Vertical rectangle implies x. Horizontal rectangle implies y. Okay, that's step number one. So in this case, we're going to work in terms of x, because my rectangle is vertical. Next question. Is your rectangle parallel or perpendicular to axis of revolution, AOR? Not to be confused with OAR. No? Never mind. If it's parallel, what do we get? Shell. And then you would have the formula for a shell there. If it's perpendicular, then we have two other questions. Touching or not touching? If it's touching, disk. If it's not touching, washer.
There's no R
Yeah, there is right at the end. Washer? And you should know each formula for depending on which one you're using. Okay. Washer, for instance, capital R minus little r squared dx integral with a pi. Yes, sir. Okay. So in this case, I've got a vertical rectangle, means I'm working in terms of x. It is parallel to the axis of revolution because I'm going around the y-axis. Therefore, I'm using a shell. Can I erase this stuff so I can do some work here?
Yes.
We're good? All right. So get rid of this. We know we're doing a shell. So for a shell, I need two things. I need the area of the rectangle, and I need the distance that that rectangle lies away from the axis of revolution. The distance is right there. And how far is that? I don't know, so let's just call it x. Now, when things change and we're not using the x-axis, or y-axis, I mean, you still want to keep in mind the mantra that we keep talking about. Top minus bottom, right minus left. So how do I know this is x? Well, I'm at some random distance x, so x minus 0 is just x. So the distance away from the axis of revolution is just x. What's the area of that rectangle? Well, for a rectangle, I need for the area of a rectangle, I need two things. We'll do the easy one first. How wide is that rectangle? Dx, good. How tall is that rectangle?
X minus x squared.
Beautiful. Clean things up here a little bit. That's one shell. Oh, well, that's not one shell. I'll have a 2 pi out in front here. That's one shell. And I want to use calculus now. I don't want to do this an infinite number of times. I don't have that much free time. So I want to take an integral here. This is a volume. And the final piece of the puzzle, I'm taking rectangles from where to where? 0 to 6. And we're good to go. Okay, what part of that doesn't make sense? Or what part of that will you struggle with?
Top line's probably.
For those of you watching the video, I'm chewing some cantaloupe right now. Please bear with me.
Yeah, like the story.
All right, we're good.
Yeah.
Okay, so you're going to have trouble with what, Dante?
Probably the top minus bottom is more than two functions.
So one of the things to remember when you're solving these problems is anytime you're not sure of a distance, more likely it's going to come down to top minus bottom, right minus left. So for instance, I'm not sure how tall this rectangle is. If I'm not sure, I fall back on what I know, top minus bottom. The top of that is the function itself, which is at 6x minus x squared. The bottom is 0. Okay. I'm not sure how far this distance is. I know this is at x. Why is it at x? Because I put it there at x. I don't know. I'm just going to call it x. I'm not sure how long that is, though, so I'm just going to do right minus left. X minus 0.
Alright, so you have to do right minus left and top minus bottom.
Sometimes you do, yeah. And it's going to get a little bit more complicated when we start shifting off of the y-axis or the x-axis. Okay?
So
It's like three different, that's like.
Somebody was
three
choking
different-
over here. Mark.
Okay, so I'm just making a clarification question.
Sure.
So can I, say generally for everything, if it's in terms of y, it's right minus left, and if it's in terms of x, it's top minus bottom?
For the most part, that's a solid statement, yes. Okay. Go ahead.
is there ever gonna be a time where like it's shifted off of the y-axis and shifted up above the x-axis? So it's gonna be like three different functions.
I got one coming. Okay.
Will we-
Go ahead.
When would it not be when Mark said it? Will we ever do?
So notice in this particular problem, I've got a vertical rectangle. I did top minus bottom to find the height of the rectangle, but I did right minus left to figure out the distance away from the axis of revolution. Okay. But for the most part, when you're working in terms of x, it's top minus bottom. When you're working in terms of y, it's right minus left. Okay?
Why for the most part, not always?
Yeah. Because in this particular problem, I did top minus bottom and right minus left in the same problem.
Okay.
Okay, shells are the ones that cause problems. If you're in discs and washers, his statement is, to the best of my knowledge, 100% accurate. I would leave this to you. Okay. Calculator, what do you do? FN int. No calculator, what do you do?
Cry.
Good. Cry and distribute.
Then do good in terms of.
Would you cry first, then distribute, or distribute while you're crying?
Same. Distribute, then cry on it and wash it
Oh,
away.
I understand. Yeah.
Wash it away.
Wash away your work.
Just make your troubles go away by crying all over them. And
Yes.
okay, good. Distribute that. You get two separate integrals. Plug and chug. Blah, 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 blah. Okay, good. Now, before we move on, I want to make sure you're okay with this because we're going to ramp it up a little bit in the next one because we're going to shift it off an axis.
Oh, my boy. That's changing the x though, right?
Max Kleenex are up here if you need them. Oh, I did this already. Okay, here we go.
I don't know. Yeah.
That was number 5, I think. I wrote.
Wait a second, that's not x squared plus 2.
Or is it?
Mr. Reed.
Bush League. All right, we're gonna go with that. Not trust me, the picture's off a little bit because I didn't shift the parabola. My bad. Okay, but the picture will be the same. I think that's still x plus 4. It is. Okay, good. And then we're still going around x equals 5. And I already drew my rectangle in there. Now, the weird thing about this is sometimes you're not going to have the rectangle to rely on. You're going to need to draw your own rectangle. So the first decision you're going to make is, what do I want my rectangle to look like? Could I do this problem as a vertical rectangle? The answer is yes, but it would be a train wreck. Why would it be a train wreck? Because the top changes partway through. This bottom part is going from function to function, and I would need at least two separate integrals, and both of those integrals could be nasty. So I'm not going to do that. I'm going to stay with one rectangle going vertical. Since it's vertical, I'm working in terms of x. Am I parallel or perpendicular to the axis of revolution? Parallel, which means I'm doing shells. Especially since the top line of this slide says using shells to find the volume. Did anybody notice that?
I do not.
Okay, just checking.
Say that again.
Knowing that we are doing shells, we need two things. We need the distance from the axis of revolution for that rectangle, and we need the area of the rectangle. Let's do the area of the rectangle first because I think that's a little bit easier. All right, so this is volume. We're going to have a 2 pi there because it's a shell. I'm going to take an integral eventually. We'll come back to that. What's the area of that rectangle? We'll do the easy part first. How wide is it? Dx. Good. We'll slap that on the back end. How tall is that rectangle? I don't know. So what do I do? Top minus bottom. Good. I don't know a distance. Go back to our two mantras, top minus bottom, or right minus left.
Biggest piece.
Bad timing on my part, I grabbed a big chunk. Tell us a story while I'm chewing.
Ooh, about what?
Your artistic talent again.
Oh.
Did you erase the picture?
Yeah, well, he erased it.
Did you say where you're going to school yet?
Yeah, it was
Okay. Good story.
Thanks.
Top minus bottom, what's on the top? Good. Just to be sure, I'm going to put it in parentheses. I probably don't need it, but better safe than sorry. What's the bottom? X squared plus 2. Good. Oh, and I forgot something. I probably should have left room here, but I'll put it. No. This is sloppy math. I'm sorry.
Couldn't you just erase?
I could erase, but I'm too lazy. I'd have to walk all the way over there.
I understand.
America.
Wait till you.
How far is that rectangle from the axis of revolution?
5 minus
I want to know that distance.
5 minus x.
5 minus x. Very good. Does it say it up there somewhere? No, you did that on your own. Very good. That's a 5, believe it or not. 5 minus x. Is everybody okay with that step?
No.
I don't know the distance. So what do? You go back to the mantra. Right minus left. On the right is our line, 5. On the left is the rectangle. Well, where'd I slap that rectangle in? I put it in at x. Ooh. Last thing, we're integrating from where to where? Good. -1 to... Wait, I don't know if that's accurate. I think my picture's off. Okay, hold on. X squared plus 2 is equal to x plus 4. So x squared minus x minus 2 equals 0. So x... -1 and 2. Is that what we got in the picture? Yeah, okay, we're good. All done. Again, I'm going to rewrite this because it's bothering me. 2 pi times the integral from -1 to 2 of 5 minus x times x plus 4 minus the quantity x squared plus 2, all of that times dx. Okay, now I feel better. So, Patrick, I think you're the one that asked, will it ever be shifted over and moved up? There's my rectangle floating out in the middle of nowhere. We're good to go. Because, again, it all comes down to top minus bottom, right minus left. Congo.
For the 5 minus x, you chose x because you couldn't put the rectangle anywhere, so you just used that.
Just called it x. Not sure where it is, it's at x.
Yeah, we have the rectangle horizontal. That just means that the direction is y. So it'll be like 5 minus y.
Yeah, assuming you were doing it over a horizontal line, because if it was that way, then this way we get a disk curve motion. Anybody else? Again, fn int or multiply it out. Probably want to fn int that bad boy. Because it looks like you're going to get a cubic in there somewhere. Yeah, not fun. Okay, can I erase?
Yeah.
Okay.
Do anything you want. Free country.
This is America. Oh, look, I did the work. Why do I keep doing the work that I already have?
Practice.
Redemption from yesterday.
Oh, yeah, here, I did multiply it out. Yeah. Oh, you guys. I wish I'd like to say I went home and did all this just so I could feel better about myself. And I didn't. Okay, so now let's look at one where we got some weirdness going on. Do you have any idea what the graph of 2y cubed minus y to the 4th looks like?
No.
I don't either. But I bet you if I click it, there's a picture of it. Yep, there it is.
Oh.
What do you mean you don't know what it looks like?
That is crazy.
That looks like it looks like a bun cake. Or like what is
It does look like a bun cake.
It does.
Yeah, but I think a bun cake, just to be nitpicky and nerdy, a bun cake I think has a hole in the middle. This wouldn't have a hole. but it's pretty darn close to a bunt cake. Bunt cake. B-U-N-D-T. Bunt.
Bunt cakes. Nothing but cakes.
What store?
Nothing but cakes.
There's one in Ranchers.
It's so good.
Oh, are those a little?
Yeah.
You can also get midnight of it. It's
Come on, go, have a story.
It's like this.
Oh, that's perfect time.
Yeah,
Okay.
try reading all the numbers.
So like, our grill keeps moving to the middle of the yard, and no one knows why. And like, we don't know what's going on, and I don't know if my dad's just messing with me, because he texts me about it every time. Because like, I'll be like gone somewhere, and he'll be like, "The grill's moved again," and I come home and it's like in the middle of the yard. So I don't know what that is.
So you're suggesting, if I'm understanding your story correctly, one of two things. Your dad is trying to drive you insane,
Or
or your house
aliens.
is haunted.
Yeah, I said
Or
that.
aliens.
Either one, but I don't
Someone
know.
sneaks
So
in
why
your
would he
house,
text you about it?
moves your grill and then
Well, he does
leaves.
say that, but like usually he makes me go look at it first, and like.
And he's
then-
definitely messing with
It's
I don't think so. because-
There was a college friend of mine who was one of the few guys in the house that had a car. And so we stole his keys one night and made a copy of his car key. And the only thing we did small changes every time. So like his headrest would end up in the trunk. Or we'd move it one space to the right. Or just little things enough that he started wondering what was going on.
Like a grill?
He did in fact go insane.
I honestly, like, it's driving me crazy. Like, I wanna put like a video camera in the backyard, like.
They're dirt cheap now.
I don't know, okay, I don't think it's him though, cause the first time it happened, it's definitely not my sister. We had like workers over, and then he thought they moved it, but then they've been gone for a very long time.
The dog.
I saw this prank idea yesterday where if you have like some access to somebody's car, you take like you can go to like an auto shop and ask them for discarded window glass, and most of the time they just have it and they'll just give it to you, and you can like spread it near their window and roll down their window and then have a rock with a note like sitting on their seat.
That's really good.
Yeah.
No, but keep the window rolled up.
Who's gonna think to
That's
try
the thing.
to
Who's
gonna think?
Oh yeah. Well, that was the other thing is somebody said you could mess with them and put the glass on the ground and the rock inside, but keep the window rolled up.
And put their keys inside the car too, so they're locked out of
That's harder to do than you think. A lot of new cars, it's almost impossible to lock your keys in the car. Like I can't do it on my car.
I can do it.
It's almost impossible.
Why is it?
I can't do it.
I don't know, it's got some sensor or something in it that if your keys are in the car and you try to lock it, it just beeps at you like you're an idiot. It won't tell you, it just beeps at you. Beep, 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 you know, it's like, I'm supposed to figure out, are my headlights on, is my trunk open, did I leave the keys in the car, any of the list of possible stupid things I could do with a car, it just beeps at you, it doesn't narrow it down to A through F, it just says, you did one of these bad things.
New invention.
All right, let's get back to this. We'll deal with the grill dilemma later. Ran the rectangle horizontally. Why horizontally? Because this puppy is in terms of y, and I don't know how to solve for y in this case. Okay, sure, I can factor out a y cubed, but I can't isolate the y. So that's pretty much forcing me to use a horizontal rectangle. And I'm spinning it around the, that's a typo. It should be, no, that's right. So it's bound by that function, the y-axis, and it's revolved around the x-axis. It's parallel to the x-axis, so we're using shells again, because we're in the section on shells, and it says using shells to find the volume. And now we just start doing it. Okay. Volume is equal to 2 pi times the integral. We'll go in order this time. We're taking integral from where to where? 0 to 2. Remember, we're working in terms of y, so when you try to figure out, well, where am I coming up here? It's not 0 if you take the y value, which is 2. Now, if you didn't have that value, you'd have to plug 0 in for y, or 0 in for x and solve for y and do all that fun stuff, but it's on the graph there. Okay, how far is that rectangle away from the axis of revolution? Y. Good. Top minus bottom. Y minus 0. How big is that rectangle? How wide is it?
2y.
Good. 2y cubed minus y to the 4th. Minus 0, but again, we don't need the 0. And how thick is it? dy, all done. Now, some people would argue that shells are easier because you're not squaring any terms. You don't have to find 2 radii. It's just a straightforward area of the rectangle times the distance away times 2 pi. In a number of problems,
Why do you keep doing this to yourself?
Takes
Keep
more
doing it
bites.
to us.
I think you just want to make his lesson longer.
what's that?
It's gonna be a
I want to make the lesson last longer?
Yeah.
Why?
I don't know.
Oh, he's paying attention.
Depending on the problem, if it doesn't tell you what method to use, you can use a number of different methods. You can choose which direction your rectangle goes. You can choose whether you want to use shells or discs or washers. Other times it'll tell you. And so through practice, you'll get a better idea of which method you should be using. By the way, have we talked about how to f at int when it's in terms of y?
No.
You just do it in
do
terms of
alpha
x.
one.
You could use y on your calculator, go to alpha y, or just do it in terms of x, you get the same answer. Okay, so just plug x's in there and you'll get the same answer. It just takes that function and turns it upwards, but again, you'll get the same answer. I don't know, it's pretty good bing though, isn't it? Yeah. Who was the bing? Who binged? Luke, is that you? It's a solid bing.
Who's the R guy?
It's an R.
Okay, we're all done.
Someone's like, yes,
Oh, shell.
Oh, shell.
Come on.
Wait, what was the design
It's
yesterday?
literally spelled out for you.
Shell cooking gas heater.
Here and
Girls have
Yes, Katie, thank you.
No, I was trying to help.
All right, so you should be good now with all this 7-3 stuff. So the 2 days of 7-3, and then tomorrow is listed as a review day because we're going to start the review assignment before the test for a variety of calendar reasons, and there's a quiz on Thursday. However, tomorrow I'm going to go back and get caught up with that section on 7-2 that we missed. So it's not just going to be coming to work on review. We're going to go over some of these shell problems. And then I'm going to take probably 15-20 minutes and talk about cross-sectional volumes.
Is that another quiz on Thursday?
That's a great question. I don't know.
Okay.
Are we gonna have
Wait, yeah, I do too.
That's also a great question. I'll let you know.
Please let us know before the day of the.
I don't know. It's on the calendar. Sometime next week.
What? I mean.